Okay, number 5 says find the instantaneous rate of change of t with respect to x if t equals 6x squared over minus 1 over x. So first I would write the formula to find that, which is f of x plus h minus f of x over h. And then I would substitute the equation in for x everywhere I saw it. So it would be 6x plus h squared minus 1 over x plus h minus 6x squared minus 1 over x over h. And then I would take that and it would be 6x squared minus 12xh plus 6h squared minus 1 over x plus h minus 6x squared minus 1 over x all over h. And then it would come out to be, and then I would take out an x and then x plus h. I would get 6x squared minus 12xh plus 6h squared minus 1 minus 6x squared minus 1. And the 6x squared would cancel out, so I'd get x plus h, negative 12x plus xh plus 6h squared minus 2 over h would be the answer. And then for 6 it says find average rate of change of f of x equals 6x squared minus 7x plus 1 on the interval 2 to 6. So first I would write the equation, which is f of b minus f of a over b minus a. So it would be f of 6 minus f of 2 over 6 minus 2. And then I'd substitute these in. So f of 6 equals 6 times 6 squared minus 7 times 6 plus 1 equals 175. And then f of 2 equals 6 times 2 squared minus 7 times 2 plus 1 equals 11. And then I would just solve 175 minus 11 over 6 minus 2 equals 164 over 4 equals 41. And then number 7 says a ladder 5 feet long is leaning against a wall. The base of the ladder is pulled away from the wall at a rate of 6 feet per second. Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 4 feet from the wall. So first I would draw the picture. If the ladder is 5 feet, I would make this y equals 5, z equals 4, and then dy dt equals 0. So first I would write, and then I make this x. So it would be x squared plus z squared equals y squared. And then that would be x squared plus 16 equals 25. It would be x squared equals 9, so x equals 3. But z, the changing rate of the wall from the rate of the wall the ladder moving away from the wall. So dz dt would be 6 because it was given. And then, so then first I would, so after I know x equals 3 and I'm trying to find this angle, I could use sine theta. Sine theta equals, sine theta equals opposite, so z over adjacent or hypotenuse, which is y, and then I would take the derivative of that, which would be cosine theta d theta over dt equals 5, or equals y d z dt minus z dy dt over y squared. And then I'd substitute in, which would be cosine theta, which would be adjacent over hypotenuse, which would be 3/5 d theta dt equals y. So 5 times 6 minus z, 4 times dy dt, which is 0 because it's constant, over y squared, so over 25, equals 30 over 25 equals 3/5 d theta dt multiplied by 5/3. Thirds, that would be 5, 1, 10, which would be 1/2 d equals d theta dt. And that would be what the angle equals.